I first heard about FHE when I was accepted for the PhD position at NTNU, because it was one of the topics that was proposed to me for the PhD. And at the time, I was really excited about it because I had specialized in algebra during my master's, and there's the word homomorphism in FHE. So I thought this is going to be really cool math. There I'm probably a little bit out of the common answers because my favorite scheme is BGV. And I think it's just because it was the first scheme I ever worked with, and also one of the first ever papers I read about FHE. So there's a little bit the joy of the beginning that is in there, but also because I think it's just really neat. It's simple, but it's quite powerful. And I really, really like the idea of modular switching. So when I started the PhD, what I found most exciting was the idea that it's possible to do meaningful computations on encrypted data, because of course you can basically add and multiply any ciphertext, but the result won't necessarily tell you a lot. And so the idea that this is possible, and also the wide range of application that this can have, and that there are so many different use cases to which you can apply FHE and find a good solution for, and therefore that you have a big variety of different things and different approaches you can work with. So I would say there have been two. One was definitely there is a lot of things people don't write in the preliminaries anymore because it is just known to the community, but which when you come new to the field, there are so many underlying things that are not quite spelled out that you don't find, or which is probably has been written down in one paper somewhere, but which then thereafter is never explained but just used. So to give an example, it took me a long time to understand what the RNS variant of, for example, CKKS or BGB is, or why we're representing the numbers over the interval minus Q half to Q half and not over ZQ. And all those little subtleties that just are written, that everybody does, but that are not quite clear when starting. And the second thing is this, because all the schemes outwardly look quite the same. So if you look at the formulas for encryption and decryption for, say, for example, BGB and CKKS, but for some details, they more or less the same thing is happening there. And yet the two schemes behave vastly differently in many aspects relating to security, performance, and noise growth. And then to understand all those subtle differences that, for example, rescaling and modular switching, they look quite the same on paper, and yet they do completely different things. And therefore, you can very easily end up in a trap if you just assume that a thing that's true for CKKS is true for BGB or the other way around. I don't think I've got a very good answer to that because I usually stayed quite on the theory side of FHE. So I'm not quite sure what to say. The performance of multiplications. Well, actually, I would rather like to know how to get into FHE really myself, but I don't quite know.